First of all, I'll introduce myself. My name is Masuzyo M'tonga. I'm an engineer with the ISA EF section. These are just some of the key terminologies. The first one is concentrate. Concentrate is our primary material. That is what we use to obtain the copper. So the second one is flux. What flux is? These are materials that we use to help us separate the copper from other impurities in the concentrate. So when we say flux, we are talking of materials such as limestone, silica sand. So those are fluxes. The third one is a washing bay. A washing bay is simply just a system that we use to recover material that might be lost. Then the next one is a press filter machine. So basically this machine is used to separate like solid material from liquid material. The third one is a conveyor belt. I think most of us are familiar with what the conveyor belt is. Then we have magnetite. So magnetite is an iron oxide. This is produced during the smelting process. We have here is electrode. An electrode is a piece of equipment that transfers electricity. Then the third one is feeding. So feeding for us people is like just eating, but for the furnace it's more or less just put material inside. And then discharge. What discharge is basically to remove from something. It means you're discharging. So in our context, we talk of products from the furnaces. When coming out, we refer to that as discharge. Then we've got lancing. Lancing in the context of ISA refers to, it means opening the furnace. The blocking machine. Blocking, it means to cover. So a blocking machine we are using to cover a tap hole, which is like a place where discharge coming out. Then blending. So blending is same as mixing. Another one is temperature. Many of us know temperature is amount of hotness, to measure amount of hotness. Then we have matte grade. What matte grade is the amount of copper in matte. So slag. Slag is a product from the smelting process. And then this is where the impurities are. Then the matte is now what contains the copper. This is what we want in smelting. Then the feed rate is just the amount at which you put. If eating fast, then feed rate high. If eating slow, feed rate is low. Then we have a tap hole. So a tap hole is basically just a hole at the base of the furnace. So this tap hole is where the material comes out. Then we have a tapping machine. The tapping machine is a machine that we use to tap material from the furnace. In other words, it is a machine that we use to open the furnace so that material can flow out. Then a ladle. A ladle basically is like a pot where we put material. So we have different types of ladles. We have slag ladles, which carry the slag. Then we have matte ladles, which also carry the matte. Slag carrier. A slag carrier is a mobile equipment. It moves. But because we're calling it a slag carrier, then we know it is carrying slag. Then a matte ladle carrier. So this one is also a mobile equipment. It moves. So this one, like a slag carrier taking slag ladle. Matte ladle carrier taking matte ladle. Then we have emulsion. Emulsion basically is a mixture. At ISA, when we say emulsion, we are talking of what is in the ISA furnace. Because in the ISA furnace, we have matte and slag, it's mixed. So that is what we call an emulsion. Then we've got sampling. Sampling is basically taking a sample so that we can test what is it we have. ISA EF section, okay? So basically we have four major operating sites. The first one is the concentrate shed. Then the second one, we have a feeding plant. After the feeding plant, now we get to the big guys now, the ISA furnace itself, okay? Then after the ISA furnace, we have a matte settling electric furnace, or sometimes it can just be called EF or MSEF. It's the same thing. So these are the major operating sites that we have under ISA EF section. And then, so here we have we have a simple input-output flowchart of how material moves around in relation to the ISA section. This is the ISA furnace. The input to the ISA furnace, we are getting concentrate, which is coming through the feeding plant. Then we also have other materials like oxygen that we can put in. So here at the ISA furnace, we have two products. There's the off gas. So this off gas goes through a waste heat boiler and an ESP, what we call an electrostatic precipitator. So at this stage, the gas is being cleaned to remove the dust. As the gas moves, the dust will be coming down and be sent back to our concentrate shed, meaning that dust comes back to ISA. And then the gas will go on to acid plant to make sulfuric acid. Because we said two products, off gas and the emulsion. So now the emulsion, which is the mixture of matte and slag. Now that emulsion will now go to the MSEF, the electric furnace, for settling. We put in the emulsion, then we get matte and slag. So the slag will come out from the EF furnace and it will be sent to slag flotation. Okay, and then slag flotation will float it and create CCS slag concentrate, which again will come back to ISA. Then the second product here, which is the matte. The matte will go to the converters. And then also from the converters, they've got the off gas going through the same process there with the boiler and the ESP, where dust is coming out. And all that dust that is coming from all ESP, ESP for converter, ESP for ISA, all that dust coming back to ISA at the concentrate shed so that we can feed it again. So this is basically just the same as the same flowchart. Just this one has got better pictures for understanding. So the furnace, the ISA furnace, we've got the concentrate shed. We also have the oxygen plant pumping the oxygen, just like before. This one is the same as that one, but just with just pictures. The emulsion will go to the MSEF. The MSEF there, you have the matte going to the converters, the off gas as well going through the ESP, then acid plant. From the converters to go to the anode furnace as blister copper, then to be cast, and then we get our final anodes under the anode section. But this part is not ISA section. So ISA section is just here. When we talk of the ISA furnace, the major inputs, we have concentrates going in, we have flux going in, we have oxygen going in, we also have rivets, which we said that come back, so we also have rivets and also diesel. All these go into the ISA furnace. And then at the EF furnace, so we have the matte slag emulsion as input. We also do receive return slag from the converters. So this is just the inputs that we have in the section. When we talk of the outputs, for the ISA furnace, we're talking about the matte slag emulsion coming out. It's an output. Also, we have the off gas. Okay, here we're saying SO2 rich off gas. And then at the EF or the MSEF, okay, there the products are matte. The matte must be between 60 to 63% copper. And also slag. The range is within 0.75 to 0.85% copper. And then also even at the electric furnace, there's also the SO2 rich off gas. And that gas is going all the way to acid plant. So now we go into these sites. Okay, so the first site is the concentrate shed. The concentrate shed basically is a site that is designed to receive, store, and prepare material. Now, what materials are we talking about? Concentrates, our fluxes, limestone, silica sand, all those are stored at the concentrate shed. And also we've got what we call auxiliary materials. Auxiliary materials, these are materials that are not directly involved in creating copper, but they can be used, such as timbers. So we also have a site where we do store timber. The concentrate shed on its own has got two types of storage. It has open area storage sites. Then we also have a compartmental storage. So what this one means is it has got a roof and it has got compartments. These are the two types of sites that we have at the concentrate shed. Open area is a site like this one. We also have now a compartmental type of storage. A part of the concentrate shed, we have what we call a washing bay. Washing bay is basically a system that we use to recover material that can be lost. When the concentrate is stored, it can be dry. So all this material can easily go away as dust. So at the concentrate shed, we are using a lot of water. So this water traps the dust, moves through a drainage, and goes to a pond. So now this pond, we have pumps. This pump will suck this material, send it to a press filter machine, where we'll separate the material and the water, and feed it also into our concentrate shed, and it can go into ISA. Another thing that we do at the washing bay is to ensure that the trucks start to bring the concentrate, because the trucks, they can carry concentrate also around the tires. So before going, we wash the tires. So by washing, also that water is going back to that pond again. The pump again takes the press filter machine, separates, we get the material, put into our concentrate shed. That way we are recovering what can be lost. The second part of the concentrate shed area, is what we call rivets crusher site. The rivets crusher site is a site where we are crushing rivets. When the discharge comes out, there are solidified materials, like the material becomes hard, but still has copper. So we cannot throw it away because it's what we want. So we will take that material, take it to the rivets crusher, crush it, feed it into ISA again. So the rivets crusher there, we have got 2 crushers and vibrating screen. And also we have a small crusher called the paste crusher that we are using to crush paste. We go on to the second operating site, which is the feeding plant. The feeding plant is responsible for blending the material and transferring it to the ISA furnace. We have got 12 bins in the feeding plant. So in these bins, there's material. This material from the 12 bins is taken using constant feeder belts. Then it's taking this material and throwing this material into what we call a main conveyor belt. We have got 2 main conveyor belts. It takes material from the bin, puts onto main conveyor belt number 1, then from main conveyor belt number 1, it will take to main conveyor belt number 2. And by doing that, the material is being mixed. As material falls, moves, it's being mixed or blended. And then that is what we send to ISA furnace as our final concentrate to be smelted. This is a picture of long belt number 1. You can see the color of the material is very different. So this shows us that different types of material is going onto this belt, meaning all this material must be mixed. And then the second picture is the top of the bins. So from the bins, the material will go into the belts. Like I said, we have got 12 bins. Bin number 1, 2, 3, 4, 9, 10. Those we're using them for feeding concentrates. Then we have got bin number 5, number 6, number 7. These are used for fluxes. We also have bin number 8 and bin number 12. These we use them for what we call cold materials or rivets. So after blending, this material now goes to the ISA furnace. So now we'll look at the ISA furnace. The ISA furnace is, I can say it is big barrel. This barrel has got what we call a lance, another pipe that goes in. When this concentrate from feeding plant has been blended, it comes all the way into the ISA furnace, falls into the ISA furnace, and then through that other lance we are putting oxygen. The oxygen and the concentrates, these they mix to react and cause smelting. The concentrate plus the flux mix with the oxygen that we are blowing in, then it will form a matte and slag emulsion, or simply just matte and slag. Also an off gas. During smelting, there are some parameters that we monitor. Temperature, we're keeping it at 1175 degrees Celsius to 1185 degrees Celsius. And also matte grade is between 60 to 63% copper. The temperature, we do it about 13 to 15 kPa. Everything that we do in the furnace comes out at what we call the tapping flow. The tapping flow, or just say third flow. Tapping flow is where we are discharging. We have 2 launders. So launders is where material comes out. To open the furnace, we are using a tapping machine. We open the furnace, we discharge the material, which is the emulsion, and this emulsion is going to the electric settling furnace to separate. Okay, so these are pictures from the third floor. This is what it looks like during operation. So this is the tapping machine. This side we have a drill gun, and then on the other side we have a clay gun. These are pictures of the launders, and this is how the emulsion comes out. These are some of the parameters that I said before. So matte grade is 60 to 63. Temperature 1175 to 1185. And then the tip pressure is 13 to 15 kPa. So now, electric furnace, what it does is just to allow for separation of matte and slag. It uses electricity to facilitate separation. This electricity is converted from electricity to heat, okay, because of slag resistance, you know, because the electric furnace has got 3 electrodes that are submerged from the top. These electrodes are inserted into the slag. Because of resistance, it produces heat, and that keeps the furnace hot, so that the matte and slag can separate. The matte settles at the bottom, the slag will settle at the top, and like that we can separate. The electric furnace has got 2 discharge points. We have got what we are calling a matte position and slag position. It's matte going one way, slag going one way. So we'll look at the matte position. The matte position is a position where we are tapping matte. Here at EF, opening and closing are done manually. So to open, we use the method that I called lancing, okay, where we get a steel pipe, connect the hose pipe and oxygen, then fire it up, then bend the tapo. That is one major difference between the opening at the ISA and the EF. And then for closing, we have a blocking machine. So this blocking machine, we put a matte ball and then we swing it manually. Need enough strength to close. These are pictures also of matte position. So the slag comes out at the slag position. Like the matte is opened and closed manually. Yeah. So this is the slag position. Slag position, what you call slag skimming. For matte, it's tapping. Okay. Then for slag, is skimming. Some of the things we also take note of for the slag is that we have to minimize the amount of, to reduce the amount of copper going to slag. Our target range is less than 1. So usually about 0.75, 0.85. So this is a picture also showing the lancing, the opening of the slag tapo, slag position. This has been our presentation. So in conclusion, what we can say about the operations of the ISA-EF section is that the main aim is it is the primary section. It is what begins the copper making process. We do not get the final product, but we merely just feed other sections so that we can get the final product at the end of the day. There's still lots of things that we do under ISA-EF section, like safety inspections, we do equipment inspection. All these things are done to facilitate what we've explained. So this has been our presentation. I hope many have understood what I was saying. So here is where I end. Thank you.